This brings us to page 378 in the book, definition 2. This is in section 5.2, and this is the definition of the definite integral. This should look familiar now. All the pieces and parts of this long definition, we've really been working with those for the past 2 class lessons, trying to lay the foundation for this definition. If f is a function defined on the closed interval x between a and b, we divide the interval ab into n subintervals of equal width. The width of the subinterval, delta x, is b minus a over n. Think about this 4-step process we've been emphasizing in the past 2 lessons. We let x0, x1, x2, x3, x4, xn, by the way, x sub 0, remember, x sub 0 is a, x sub n is b, and we let these tick marks be the endpoints of these subintervals of equal width. And remember, we pick a x sub I star, x sub 1 star, x sub 2 star, x sub 3 star, etc. We pick x sub 1 star in the first subinterval. We pick x sub 2 star in the second subinterval, etc. Those could be left-hand endpoints, right-hand endpoints, random points. But x sub I star lies in the ith subinterval. When we talk about the ith subinterval, we're just talking about a typical subinterval. We're just using the ith subinterval for the first one, or the second one, or the third one, or the fourth one. Remember how the ith subinterval is x sub I minus 1 to x sub I. This is the ith subinterval. It's just a typical subinterval. We define the definite integral of f from a to b to b. Okay, this is the symbol for the definite integral of f from a to b, and we define it to be a limit of a sum. A definite integral is a limit of a sum. Its value is going to be a specific number. Remember when we evaluated the definite integral in the last lesson? We didn't call it evaluating a definite integral, but we actually went through this 4-step process. And when you go through this 4-step process, you're evaluating a definite integral. And we got the value as 8/3. The value of a definite integral is a number, not a function. The value of an indefinite integral is a function. An indefinite integral is an antiderivative. A definite integral is a limit of a sum, and that's going to give you a number. So I'm trying to emphasize, while we're looking at this definition of definite integral, I'm trying to emphasize that a definite integral means something very, very, very different from an indefinite integral. Obviously, they're going to be connected in some way, but they mean very different things. So a definite integral is just the limit of a sum. That's so very important for you to realize, because you're going to form limits of sums to find lengths of curves and volumes of solids of revolution, things like that in Cal 2. So this process is important to understand. The limit of what sum? It's the sum of areas of rectangles. And this f of x sub I star is just the height of the ith rectangle, and the delta x is just the width of the ith rectangle. So when we write this definite integral symbol of f of x dx from a to b, notice we're dropping the star, the subscripts, the delta, we're just writing d. We're just writing much more simple notation. But this notation, this short notation, this simpler notation, should make us think of this meaning, the limit of a sum, with all those subscripts and additional symbols there. Now, they say in this definition that the definite integral from a to b, of f from a to b, is the limit of this sum, provided the limit exists and gives the same value for all possible choices of sample points x sub I star. Remember, we could use right-hand endpoints, left-hand endpoints, midpoints. Now, you'll get different answers if you're just using 4 rectangles or 5 rectangles to estimate area or to approximate area. You'll get different answers if you use left-hand endpoints from right-hand endpoints, right? But if you take the limit as n approaches infinity and use infinitely many rectangles, you'll always get the same answer, provided your function is continuous, provided your function doesn't have any breaks in it, okay? And those are the kind of the functions that we'll be using here in Cal 1. So provided this limit exists and gives the same value for all possible choices, in Cal 1 we don't have to worry about that because we're going to use continuous functions and on our closed interval AB, and so it really won't matter if we do use left-hand endpoints, right-hand endpoints, we'll get the same value when we take the limit. Okay, if the limit does exist, we say the function is integrable on AB. Okay, in this symbolism, f of x is called the integrand, and a and b are called the limits of integration. A is called the lower limit, B is called the upper limit. Now this term limits of integration is not to be confused with this limit here in the limit of a sum, right? A definite integral is the limit of a sum. A and B are limits of integration. That's not the same meaning of limit. By saying A and B are limits of integration, we just mean our closed interval is AB. We don't mean formal definition of limit. Okay, you really need to understand this definition. It is so very important. Hopefully, in the work that we've done in the past 2 lessons, first approximating these definite integrals with Riemann sums and a finite number of rectangles, and then actually using this definition to find an exact area. You've experienced these 4 steps in this 4-step process, which really is this definition of definite integral. This 4-step process lays out this definition of definite integral.